in addition to the investigations with human DNA, one of the things that I really want to do is an experiment that I've had in mind for a couple of years now, and it's a way to empirically test what we hypothesize in the Unified Space Memory Network. So in the USN paper, one of the key things that we're discussing is a natural mechanism by which information is distributed or shared across the space memory network, and that this information, the reception of this information, is what directs the evolution and development of systems to a large degree, so that it's not completely random, as is presupposed under conventional theory. There is a certain degree of directionality that is imparted to the evolution and development of physical systems via this feedback feed-forward mechanism that's facilitated through the structure of space. Well, so we can test that. We can set up a little experiment where we see, can we transmit information through the space memory network that has a noticeable, a demonstrable effect on the evolutionary pathway of an organism. So we would use bacteria. Bacteria don't mind so much being experimented with because as long as they've got nutrients, they're happy, and they can live on just about anything. But so one of the things that we do to test this is we could get a strain that has one of their key genes knocked out. So an example of this would be like the LAC-Z gene in E. coli. This gene encodes the enzyme that metabolizes the sugar lactose. So if you have this strain with that gene knocked out and you put them onto a culture media that only has lactose, they cannot survive because they can't metabolize that sugar. Whereas wild type E. coli that don't have this gene knocked out, they can live on a media with lactose. Well, what we would do is have two groups, each with the LAC-Z gene knocked out, and we would provide enough nutrients like glucose and fructose that they're able to survive, but in diminishing amounts with an abundance of lactose, so that their survivability would be much greater if they were able to somehow reactivate the LAC-Z gene and metabolize the lactose. So over the course of a couple of months, or however long it might be, a year or more, you keep testing to see if this LAC-Z gene has been reactivated in either of these groups. As soon as you find that, because this happens, then you expose that group that has reactivation of the LAC-Z gene to a electromagnetic field that is very coherent, a very structured electromagnetic field that is facilitating information exchange with the Unified Space Memory Network. Now, what this would show is that the reason why one group was able to reactivate the LAC-Z gene and the other was not, was because of something you did in the future to actually enable the transmission of the necessary information to reactivate that gene to the organism. And so there's a number of different kind of permutations of this experiment that can be done to show that there is directed adaptive evolution of living organisms via information exchange with the Unified Space Memory Network.